Okay, so this is trig question from one of the sheets that you sent me, trig question number 33. The only problem is I've lost the sheet, so I've got to rely on memory and some of the things that I jotted down. So here we go. Basic idea, something along the lines of there's a crossroad, there's an observation post, a certain distance and a bearing from that crossroad, and there's a second observation post, a certain distance and direction from the first observation post. So the crossroad first, I'll call that C for the crossroad, just to simplify what we've got on our diagram. Because they give me a bearing, I'm looking down on top of this. All right. So I'm going to draw from my crossroad C, I'm going to draw a north line. And that's going to allow me then to put my bearing in. The bearings, true bearings, are always clockwise from north. This one I think was 50 degrees. Something like that, whatever. Doesn't really matter what. This is just a sketch, so you don't need to measure it or anything like that. And that took me to my first observation post. I'll call it OP1. And it was 48 kilometres away. And then from the first observation post, there was another observation post due east. So I've drawn a north line facing straight up, which means due east is going to be going directly across to the right. So somewhere along there, it was about 28 kilometres. Again, like the angle, you don't really need to measure this, or even have it to scale. It really doesn't matter. It's just a sketch for you to, as a guide to see what's going on. So that's the basic scenario, and they're asking us some questions about this. The first question was just focused on the observation post, so I didn't really need the second observation post. It's really just that part of the question. And they're asking me to get to the observation post, how far north and how far east have you got to go? All right. Obviously, you probably just go straight along this line, but how far north is that position from here, and how far east is that position from the crossroad? So what I'm going to do is I'm going to forget the second observation post, and I'm just going to draw a new diagram, basically what I've got here, but without the second observation post. And I'm going to turn it into a complete triangle. All right, it'll be right angled because that line there goes north, this line goes east, so their directions are at right angles to each other. I know I've got a 50-degree angle inside that right angle triangle just there, and I know I've got a side which is 48 kilometres long. And I basically want to work out how far north and how far east is this point from that point. So basically I want these two other dimensions in that right angle triangle. This one, sorry, my battery is running out low on my iPad. This one is, hopefully you recognise it, that one is the hypotenuse, which I'm just going to call from now on, I've written it out there, but I'm just going to call that H for hypotenuse. This side, which I'm trying to find, I called it N for north, but that one is actually, because it's directly next to that 50-degree angle, that's hopefully one you recognise as the adjacent side, which from now on I'm just going to call A. And this side here, in a right angle triangle, when you've got an adjacent and hypotenuse, the third one is just the opposite side. Opposite because it's literally opposite that, in the triangle, opposite the 50-degree angle. So I'm trying to find E and N. I've got a right angle triangle. I've got two sides, a side and an angle, so I can use a basic trig ratios. To get E, let's work it out. So to find E, so I want to find E. E is the opposite side. I've got 48, which is the hypotenuse, and I've got a 50-degree angle. With that information, opposite and hypotenuse, that's going to be a job for the sine ratio, which we say the sine of the angle, which I've just called A. It doesn't, you might call it theta, doesn't really matter. The sine of the angle is equal to the opposite side divided by the hypotenuse. That's my trig ratio. And then I can do that, let me just move that up a little bit. I can solve that problem for this particular information. So the sine of the angle is actually the sine of 50-degree angle. The opposite side is the one that I'm calling E for the east distance. And the hypotenuse is 48. So that, I've basically got a relatively straightforward problem to solve. Now my calculator's just turned itself off. So just bear with me while I flush it back up again. So the sine of 50 degrees, that's just a standard value. We can work that out in calculator. And it turns out to be, I'll just go to 3 decimal places, 0.766. And that's equal to E divided by 48, the east side divided by 48. I can easily get the east side. I just need to get rid of this divide by 48. To do that, I just do the opposite function, the inverse function. Inverse of dividing is just multiplying, so I just multiply by 48. I do that to both sides, just to sort of balance the equal sign there. And that divide by and times cancel each other out, just to leave me with E. And over here I've just got 48 times 0.766, which I'll just see if I can work out. Sorry, I'm doing this on Google. I left my calculator at school, so that's about 36.77, and that would be kilometres. And so that is my east distance. I can basically do pretty much exactly the same thing to find the north distance. That will be, though, because the north side is my adjacent side, I'm not going to be using sine. I'll probably use cosine. In fact, while I'm here, let's do it. So to find the north side, which I call n, n is my adjacent side. I've got the hypotenuse. Actually, now that I've worked out the opposite side, I could also use tan as well. But I usually stick, this is not precise because I've rounded the value, so I use the precise value 48. So I prefer to stick with values that you know exactly. I know that's exactly 48. And I've still got my 50-degree angle. I'm going to use the cosine. Cosine of the angle is the adjacent side divided by the hypotenuse. That's the standard cosine trig ratio. And so let's plug in the things I've got. Cos of 50 is the adjacent side, which I happen to call n. You can call them whatever you like. I just call it n for north. Divided by the hypotenuse, divided by 48. You can see basically I've got pretty much exactly the same thing. It's just instead of sine of 50, it's cos of 50. But my working is going to be the same. It won't be 0.766 because it's the cos of 50. Let's work out what that is. Cos of 50 is 0.643. If I go to 3 decimal places, 0.643. That's n divided by 48. Do the inverse function, times by 48 both sides to cancel that out. And I'll be left with the north side is whatever that is. Let's work that out. Times 48 by 0.643. And I get 30.85 kilometres. And those are the answers to part A. I'll go on and try and do the others, but we'll just leave it for now when I see if I can actually do anything with this video.